Simplify radicals. Does that even sound familiar, the word simplifying radicals? Okay, in Algebra 1, you should have learned how to do it, and if you came from MMA, then you should have done it in Algebra 1 and in MMA. So people that came from MMA have more experience doing it than the ones that came from Algebra 1. And then we're going to get into Pythagorean theorem today, which most of you feel kind of comfortable with that, I think, just from some things that I've seen in the past with you. So anyway, the biggest thing is knowing how to simplify a radical. So I'm going to show you one way of how to do it, which is how most teachers prefer, especially as you get into your upper level math classes. This is how they will want you to do it. But then I'll show you another way, just in case what I had been saying to you doesn't make any sense. Okay? So, first of all, I need you to know that these guys right here are your perfect squares, because when you take the square root of them, you get pretty little whole numbers. So, these are your perfect squares. Yes, sir? I figure most people know to 225 pretty easily. And then after that, I don't really care. And the fact that we're in a calculator world and you guys get to use a calculator, then I say don't even worry about it. So like in this list, this one you may not know the square root of. So I want to make sure everybody knows where the square root is in their calculator, just in case you don't know the square root of these.
That's 33.
Do you guys know where the square root button is? Yeah, he's right above this x squared in blue there. So since he's above the x squared in blue, how do I get to him?
Second.
Okay, so I'm going to go second x squared, and then I just want to know what the square root of 625 is, because I may not know. So I just put 625 in, hit enter, and there he is. So the square root of 625 is 25. What's 225? Well, let's see. Second square root, 225, 15. So if you don't know your square roots, and I've worked with some students in the past that, come in for tutoring, and I'll say, what's the square root of 64? And I expect everybody to be able to answer me like that, but unfortunately that's not the case. So if people don't know what the square root of 64 is, take a second, make your calculator tell you. I don't really care. Now, as far as like how these work, sometimes students will ask me if I can write the list of perfect squares on the board for them. That's not something that I should have to do. It's just, you just go through this list of what's 1 times 1, 1. What's 2 times 2, 4. What's 3 times 3, 9. What's 4 times 4, 16. And then the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. What's the square root of 25? And that's because 5 times 5 makes 25. So if I didn't have this list of perfect squares right here, or if I didn't have it written on the board for you, then you just go through your own mind and you just can write them down for yourself. 1 times 1, put the answer down. 2 times 2, put the answer down. 3 times 3, put the answer down. And these guys are your perfect squares. Okay, so as long as a number is in this list, it's going to come out nice and pretty. So let's look at this list over here. Is 4 in my perfect square list? So it comes out nice and pretty. What's the square root of 4? 2. Okay, is 16 in this list? Yeah. So he comes out nice and pretty. What's the square root of 16? 4. Okay, is 25 in this list of perfect squares? So he's pretty. He's a 5. How about the square root of 100? 10. How about the square root of 144? 12. So those are all perfect squares, so they all come out nice and pretty. But what if they're not? So the first one I want to do, I'm just going to write up here. I'm going to put in a 72. So the square root of 72. Is 72 in this list of perfect squares? So that means he doesn't come out pretty. Let's just say you didn't know that. So you put the square root of 72 in your calculator. If you get a decimal, that means he doesn't come out pretty. But today I don't want decimal answers. Today I want us to try to simplify the radical. So, like I said, I'm going to show you how I want you to do it, how most upper level math classes want you to do it, and then after a while I'll show you a different way, just in case you learned a different way, or just in case what I'm about to say makes no sense to you. This is what you want to do. You want to try to find the largest number in the perfect square list that will go into 72 evenly. Some of you will be better at this than others because some of you are just better at your multiplication facts.
Did you get 72?
I just made up a problem. So I want to show you how to do it if you're not very good with your multiplication facts. If you're good with your multiplication facts, then this will probably bore you. But 72, that's what I'm trying to figure out. I'm going to go through my list of perfect squares and find the biggest guy that goes in there evenly. I'm never going to use the 1 just because 1 goes into everything. So I'm going to start with the 4. So I'm going to try 72 divided by 4. If you don't get a decimal, that means 4 goes in there evenly and it goes in 18 times. But I want to find the biggest number in the list that goes in. So to know if I found the biggest guy, look at your answer. Can 18 be divided by any of these numbers evenly? 18 can be divided by 9 evenly. So I need to keep going. So if your answer can be divided by one of these, 4 is not the largest perfect square that goes in. You need to keep on going. So I'm going to try the next perfect square in the list, which is 9. And 9 goes in there evenly, so 9 works. But let's look at our answer. Can 8 be divided by any of these evenly? It can be divided by 4. So I haven't found the biggest one yet. I'm going to keep going. I'm going to try the next one in the list, 16. I get a decimal. That means 16 doesn't go in there. I don't want to use him. I'm going to try the next one in the list, 25. I get a decimal, so 25 doesn't go in. I don't want to use him. I'm going to try the next one in the list, 36. 36 works. Now let's look at our answer. Can 2 be divided by any of these evenly besides the 1? Then we found our biggest guy. 36 goes in there, and he goes in there twice. So how you do this is you write the perfect square that you found that went in there, and you write down how many times it goes in there. So always write the perfect square first, because that's the one that can come out nice and clean. So the square root of 36, he's in the list, so he's pretty. What is the square root of 36? 6. And then is 2 in this list? So you can't take the square root of 2 and get anything pretty, so you recopy them. And there's your answer. And you can say this 6 square root of 2, 6 radical 2, 6 times the square root of 2, 6 times radical 2. Lots of ways of how to say that. Does this ring any bells from your past? Okay, so I'm going to show you this method first for several problems, and then I'll show you something else in case you don't like it. So let me make up another one real quick. I don't know what I want to use. No, I just got a cold over the weekend. No big deal. I guess I'll use 24. It's not very challenging, but that's okay. 24. Do you know what the largest perfect square is that will go into 24 evenly? Okay, let's see. I heard 16. Let's see if it does. 24 divided by 16. 16 doesn't go in there because I got a decimal. So can we find another number in the perfect square list that might go into 24? 4. So let's try 4. 4 works. Now let's look at our answer. Can 6 be divided by any of these besides the 1? Then we found him. That's the biggest guy. That's the biggest perfect square, and that's how many times he goes in. Okay, so write the perfect square first and how many times it went in second. It's the perfect square that you can clean up. Since 4 is in the list, he's nice and pretty. What is the square root of 4? 2. And times the square root of 6, because 6 isn't in the list, so you can't take the square root of it and get anything nice. So there's your answer. 2 square root of 6. Okay, so I'm going to do more of them just over here. So it tells you, write the perfect square first and then how many times second. So what's your largest perfect square up here that goes into 8 evenly? 4. And how many times does 4 go in there? Twice. Beautiful. And then the 4 is the perfect square, so that's the one I want to clean up. What's the square root of 4? 2. And then you can't take the square root of 2, so that one recopies. And there's your answer. Okay, how about 20? What's your largest perfect square that goes into that evenly? 4. And how many times? 5 times. So clean up your perfect square. What's the square root of 4? 2. And then you can't take the square root of 5 and get anything nice, so you just recopy square root of 5. Okay, how about 32? What's your largest perfect square that goes into that? 16. Oh, yay! I thought somebody might say an 8. Did anybody think an 8?
No.
Well, 8 works, it's just there's something bigger, and 16 is the something bigger. So 16 goes in there twice, and then clean up your perfect square. What's the square root of 16? 4. And then you can't take the square root of 2, so that one just recopies. Is it fun? It's so fun. You try these next two. Let's see what you do. And then I'm going to draw some sticks. I like your hair, Tori. It's gorgeous as always.
I like Cody's better than
Mm.
Thank you.
Is that because you like boys better?
Oh.
It's okay. It's just a question. I like boys better too. Joshua, you don't want to come back and start sleeping in my class again. Well, then you have to open your eyes. Like, remove your hand from your head so it can't get propped up. And then open your eyes. Yes, ma'am. Oh,
I was so like used to staying up late, sleeping late again, and then
Are we ready? Dylan Davis, can you tell me what the largest perfect square is that goes into 75?
25 and 3.
Yes, 25 goes in there 3 times. Beautiful. So what was your final answer?
5 and the square root of 3.
Yes, 5 square root of 3, because the square root of 25 is 5, and then you can't take the square root of 3. Excellent. Okay, Seth, can you tell me what your largest perfect square is that goes into 40?
4.
And how many times?
10.
So what was your final answer?
2 square root of 10.
Yes, the square root of 4 is the 2, and then you can't take the square root of 10. Okay, so I got this far with my last class, and I asked if the class wanted to see a different way of how to do it, and somebody said yes because he had no clue of what I was saying so far. So I just want to know, is there anybody in here that does not have a clue about what I'm saying so far, because I will try to say it one more time and take you back through the process one more time. And don't be shy. I know that's like, I'm not going to admit to not knowing what she's doing. But I need you to, if you don't know, I need to make sure that you say something. Is there anybody in here that doesn't have a clue? Okay, so let's try the 48 this way, and then I'm going to show you a different way. So do you know what the largest perfect square is that goes into 48? 16. And how many times does 16 go in there? 3 times. And then what would the final answer be? 4 square root of 3, because you can't take the square root of 16 is 4, and then you can't take the square root of 3. Okay, so then this is when I was going to show you a different method. So you tell me, do you want to see a different method?
Sure.
Okay, so if you don't want to see this other method, you could blink for a while. This other method, the one thing that sometimes students like about it is you can use any numbers you can think of. Whereas the method I just got done showing you, you're limited to using these perfect squares. You have to find the perfect square that goes in and how many times. So you're forced to use these numbers in the method I was just showing you. And the method I'm about to show you now, you can use any numbers you want. Just think of something that goes into 48. What's something that just pops into your mind that goes into 48? 4 and 12. Okay, so the thing about this little tree diagram is you don't have to use the perfect squares that we were using before. You can, but you don't have to. And then I keep breaking them down until I can't break them down anymore. What goes into 4?
2 and 2.
2 and 2. Okay, so now I need to break down the 12 because these don't go anymore. Not 6 and 6.
Oh, 3 and 3.
Not 4 and 3. Okay. And now I can't break down the 3 anymore, but I can break down the 4. What can go into 4? 2 and 2. Okay, so the way this works, and it's kind of weird the first time you see it, but whatever has a pair comes outside of the radical. So here's a pair of 2's. So 1 2 is going to come out. Here's another pair of 2's. So another 2 is going to come out. This 3 that doesn't have a partner, he's going to be stuck under that radical. These guys just got to come out because they had a partner to match up with. And then the ones that come out together multiply together. And then what's 2 times 2? 4. And then I can't take the square root of 3, so I recopy. And is that the same answer we got when we did it the perfect square way? Does anybody remember being shown this method before? Okay, so I don't care how you do it as long as you're able to do it. Let's make this, instead of a 450, let's make this an 80. First I want to try out the perfect square method. So the perfect square method, you're forced to use the perfect squares. So do you know what the largest perfect square is that would go into 80 evenly? 16. And how many times does 16 go in there? 5, and what would the final answer be? 4 square root of 5. Okay, so now I want to show you using the tree diagram. But with the tree diagram, you're free to use any numbers that you want. Just think of something that goes into 80. What can you think of that just goes into 80?
1 and
10 and 8. I could use 1 and 80, but if I used 1 and 80, I'm back to where I began, basically. Okay, let's keep breaking down the 10. What goes into 10? 5 and 2. I can't break those down anymore. Okay, let's break down the 8. 4 and 2. Okay, I can break down the 4. What goes into 4? 2 and 2. Okay, so remember, I'm looking for pairs. So here's one pair of 2s. So 1, 2 comes out. Here's another pair of 2s. So another 2 comes out. Those guys will multiply together. And then this 5 that didn't have a partner, he's going to go back under the radical. And then I can multiply the outside numbers together. What's 2 times 2? 4. And then I can't take the square root of 5, so I just recopy that. Is that the same answer we got doing it this way? Okay, so the main reason why I show you this is because it's less mess. And when you get into Algebra 2, your problems become much more lengthy, much more elaborate, and you don't want to necessarily have all this mess going on with everything else that you have to do in that class as well. So that's one reason why I show you this method, but if you don't like this method, then there's always this one you can use.
Okay, I'm just going to let you know, I want to pay attention, so just tell me now. Why did 450 turn to 80?
Because I just wanted to do 2 problems the perfect square way, and then the same 2 problems the tree diagram way.
So they're not related.
No, I just decided let's not do 450, let's just do 80. So that way we did 2 problems that were the same, just with 2 different methods.
Golden.
So you could kind of compare the 2. So I'm going to do it basically this way. But if anybody wants to see the tree diagram from me on any other problem, I'd be happy to do it. Okay, so next thing I want you to do, I want you to go to page 9 for just a second. We're actually going to be working on page 10, but I just wanted to show you page 9 for a moment. So we're going to start look at the Pythagorean theorem today. And most of you know what the Pythagorean theorem is. It's only good for right triangles, and it's good for finding one missing side of a right triangle. It's not for finding area of a triangle. It's not for finding perimeter of a triangle unless you needed to know a missing side. It's for finding one missing side. So you have to know 2 of the sides. If you don't know 2 of the sides, you can't use Pythagorean theorem. Okay, so you have to know 2 sides already, and it's good for one side. And then the C is the most important part of this thing. It's across from the right angle. It's called the hypotenuse. It's the longest side, and it's the one that's always by itself. And then the A and the B, it doesn't matter which one's A and which one's B. Okay, so let's try some of those. So flip the page to page 10. Looking at this picture here, first thing I want to do is identify the C. Which one's the C? X is the C. That's what's across from the right angle, so the X is the C. The other 2 numbers are the A and the B, and it doesn't matter which one's A and which one's B. So what would it look like? A squared plus B squared is C squared.
3 squared.
Yeah, so 3 squared plus 3 squared is C squared or X squared. I don't care what letter you use. I'm using the X just because that's what was originally in the picture, but it doesn't matter. Okay, for this class, just to save some time, I'm going to put most of this in my calculator. So since X is by itself on the right side, I just need to calculate the left side. So I'm just going to go 3 squared plus 3 squared in my calculator and not even have to think. And the answer to that is 18. And I know most of you could do that without a calculator. I just wanted to show you with it. So I get 18 equals X squared. But I can't leave that little squared there. Do you know how I make that little squared go away? I square root both sides. And then that gives me X is the square root of 18. Now this is where I do what I was doing a minute ago. Does the square root of 18 come out nice and pretty? No, so I want to try to break them down. So I can either do the tree diagram, the very last thing I showed you, or I can do the very first thing I showed you. What's the largest perfect square that goes into 18 and how many times? 9 goes in there, and how many times? Twice. And the final answer? 3 square root of 2. Because the square root of 9 is 3, and then you can't take the square root of 2, and that would be your final answer. Does anybody want to see me do the tree with the 18? Okay, let's look at the next picture. Which one's the C in the next one? 15 is the C. So then the 9 and the x are the a and the b. So what would it look like? A squared plus b squared equals c squared. Okay, so 9 squared plus x squared equals 15 squared. This one is different than the last one, and I'm going to make my calculator do all the work here for me for the most part. Does everybody agree if I want to get x by itself, I'm going to have to move this 9 squared? You don't agree? Okay, well, I will. If I want to get x squared by itself, I've got to get this to go away, and because it's a positive 9 squared, how would I get rid of it? So in my calculator, I am going to put in, because that just goes away, 15 squared minus 9 squared. And I'm not saying you have to do it that way. I just want to show you a way with the calculator to make it easier. So in the calculator, I'm just going to go 15 squared minus 9 squared, and that gives me 144. So my x squared comes down. I get 144. How'd you tell me to get rid of that little squared a second ago? Square root. So I square root both sides. So that's x is the square root of 144. Does that come out nice and pretty?
Yeah.
What's that? 12. So if it's a perfect square, it's going to come out nice and neat. If it's not a perfect square, I want you to try to break it down. Okay, in the third picture, which one's the C?
65.
The 65 is the C. So then the 25 and the X are the A and the B. So what's this setup going to look like? What squared plus what squared is what squared? 25 squared plus what? X squared equals 65 squared. Okay, X is not by himself, so how will I get this 25 squared to go away? Subtract it. So I'm just going to, in my calculator, take 65 squared minus 25 squared. That way I don't even have to worry about doing it in pieces. So in the calculator, I just go 65 squared minus 25 squared, and I get 3,600. So the x squared drops down, the equals drops down, the 3,600 drops down, and then what? Square root both sides. That gives me x is the square root of 3,600. Does that come out nice and pretty?
Yes.
To what?
60.
Yay! So x is 60. Pythagorean theorem seem easy enough? Okay, let's jump to this picture right here. Do you know anything about this triangle?
It has to be half of 42.
Yes. This is an isosceles triangle, since those two sides are the same length. So this distance, 42 here, this is going to be half that length. So this is going to be a what right here? A 21. And it's only because it's an isosceles triangle, and then this happens to be a perpendicular bisector right here. So you can see it's perpendicular because of the 90-degree angle, but it's also a bisector chopping that base in half. Okay, so focusing in on this triangle, I want to see if you can do it. So figure out what squared plus what squared is what squared, and then see if you can get a final answer.
Why is it putting it in parentheses?
I think it's gonna matter.
Because the calculator knows that most of the time parentheses are important, and so it just puts them
You're not
there.
doing in square, you're doing that. So it's 24. Wait, what is it? Huh?
Mhm.
Then you have to square root, which it isn't put in there. So knock back down, boys.
Work down.
Oh, see, it's
Right.
Okay, so I'm going to draw a few sticks on this one. Do most of you have it? No. And hopefully showing you the tree diagram didn't confuse you from the other method that I want you guys to use. Cody Taylor, you're my first stick. Can you tell me your equation? What squared plus what squared is what squared?
X squared plus 21 squared equals 24 squared.
Yes. X squared plus 21 squared equals 24 squared. Beautiful. Okay, so the next person, I want to know x squared equals what? Jenny.
I started off on, I did 42.
Not using the 21. So, like, if this was my problem, do you know what I would do to get x squared by itself? So we're going to subtract the 21 squared. So in the calculator, I'm going to put in 24 squared minus 21 squared. And when I do that, that makes 135. So just without me showing that step, that would be that. Okay, next person. Tori,
This is the part where I got messed up.
could you find a perfect square that went in there? No? Okay, so I'm going to go through the list with you real quick. So when you're trying to break it down, you can flip back to that front page, but the first perfect square after the 1 is a 4. 4 doesn't go in because you get a decimal. Then I'm going to try the next one in the list, which is 9. 9 goes in. And looking at this answer of 15, can 15 be divided by any of these perfect squares evenly? So that's what we want. So 9 goes in there 15 times. So 9's the perfect square that goes in there, and it goes in 15 times. And then one more stick. Austin, what's your final answer then?
3 squared root of 15, whatever.
Oh,
I got it.
no, I couldn't figure out how to square them like that.
Oh, well, that's okay. So now that you've seen this, what's the square root of 9? 3. And then you can't take the square root of 15, so that just stays 3 square root of 15. Does anybody need to see me try to do the tree with the 135?
I told you by now.
So, if you guys are bad about figuring out what perfect square goes in there, then just do what I tried to show you at the very beginning, which is what I was just showing Tori a second ago. I never mess with the 1 because 1 goes into everything. I just try the first number in the list. If you get a decimal, it doesn't go in. Try the next number in the list. If you don't get a decimal, it means it does go in there, and he might be a possible candidate. It just depends on the answer. And if the answer can't be divided evenly by any of these, then you found the biggest guy. But if this could be divided by any of these, you'd keep going through the list until you find it. Okay, the word problems. The thing about the word problems is if they don't have a picture, they're an issue. Like the first one, there's a picture, no big deal. This one, there's a picture, no big deal. This one right here, since there's no picture, that's what makes them more complicated. So I want to do this one for you. Are there any packets out there? I don't think so, Scotty. Here, you can have this one. Okay, so looking at this second problem about the tethers, it says to help support a flagpole, a 50-foot long tether is tied to the pole at a point 40 feet above the ground. The tether is pulled taut. Do you know what that means? Tight. And tied to an anchor in the ground. How far away from the base of the pole is the anchor? Okay, so I would just suggest that you read it again. If you don't know what it was saying or you don't know what to do, I would just read it again. And we've got this flagpole, so that's the first thing I'm going to do. I'm going to draw a flagpole, and I don't care what he looks like. Then it says you have this 50-foot long tether that's tied to the pole at a point 40 feet above the ground. Okay, so here's your ground, and 40 feet above the ground, you've got this 50-foot tether tied there. So the distance from the ground to where that tether is 40 feet. And the fact that you're tethering it to the ground, this is the tether. So it's 40 feet above on the flagpole, and it's pulled tight. That's your 50-foot long tether. And then it says how far away from the base of the pole is the anchor. So here's the base of your pole. Here's where it's anchored down to the ground, and it wants to know how far is that. That's the hard part about these problems, trying to draw your picture. Once you got your picture, it's easy. Which one's the C? The 50 is your C. So what would it look like? What squared plus what squared is what squared?
1 squared plus x squared equals 50 squared.
Yes, 40 squared plus x squared is 50 squared. And if anybody wanted to do x squared plus 40 squared, that's fine. Okay, x is not by himself, so how are you going to make that 40 squared go away? Subtract him. And I can just make the calculator do that. So in the calculator, I would just type in 50 squared minus 40 squared. Can somebody do that and tell me what you get? 900. Okay, so the x squared drops, you get 900. And then to move the pesky little squared, you square root both sides. Does that come out pretty? 30. And that would be feet, and that's how far away it is from the base of the pole. It's 30 feet. Okay, I've written your assignment on the board, and I wanted to give you guys some time to work on it so it won't be so overwhelming. So the first part is page 3. Page 3 is supposed to be the easy page, and this is 1 through 18 on page 3, and I do have it written on my sideboard here. So let's just do a couple of them real quick. In this top section, I'm just trying to simplify. So let's look at number 2. Square root of 81. Will that come out nice and pretty? What is it? 9, and you're done. Let's go down to number 9. Number 9, can you take the square root of 200 and get something nice and pretty? No. So I need to break them down, either with the tree or with the perfect square method. I really want to do that perfect square method. What's your largest perfect square that goes into 200? 100. And how many times does 100 go in there? Twice. And then the 100 is the perfect square, so he's the one that comes out pretty. What's the square root of 100? 10. And then you can't take the square root of 2, so that just recopies. So your answer is 10 square root of 2. So that's what 1 through 18 are like. Either they're going to come out nice and pretty, or they won't. And if they don't, you have to try to break them down. Okay, the other part of your assignment is on page 11. And on page 11, I'm going to have you start with number 10, and I'm going to have you do 10 through 20 even. That's just Pythagorean theorem, and you may have to break down your answer. So hopefully that won't take you too long, the 10 through 20. And then the 22 through 25, those are word problems, and the challenge about those is seeing if you can get those pictures drawn correctly. So you guys have about 13 minutes now. You could get a good chunk of this out of the way. And so that way I can kind of come around and help you, especially if you're struggling with simplifying the radical, because that's what's always hard.